We're going to take notes on solving absolute value equations. And the first thing we're going to look at is how to write an equation for a graph of an absolute value. So we're going to use the transformations that we've learned about and our absolute value graph. So the parent function, y equals the absolute value of x. And what that looks like is our V shape right here. So we can look at this graph that's here and tell how it's been transformed. Now we know, first of all, it has been moved to the right one and up one. So I think that should say 1. Actually, it's supposed to be up here at 2. So we're going to say it's at 1, 2, like it says it's supposed to be. So I know it's been moved to the right 1 and up 2. So in my transformed equation, to the right 1 becomes x minus 1, because remember, horizontal transformations are opposite, and up 2. Now, the other thing we want to notice about this graph is it has a vertical stretch. Now, the typical absolute value equation, they have a slope of positive 1 or negative 1. This new equation has a slope of up 2 over 1. So it has a slope of positive 2, and over here a slope of negative 2. So it has a vertical stretch by a scale factor of 2. So that's your A value that goes out in the front. So this A value represents the slope. And we'll just use the positive slope, because if we put a negative in front of that, then it reflects it over the axis. And that does not represent this equation. So that's what you would do for that one. Let's try the next one. Now the next one, I can tell that it's been reflected over the x-axis, and then it has been moved from the origin left 2 and down 3. And then we'll check the slope to see if it has any type of vertical stretch. So if I look at my slope, I go 1, 1, 1, 1. So it has a slope of 1, so there is no vertical stretch. So when I write my equation, it's a reflection over the x-axis, so A is negative 1. And then if I go to the left 2, that's represented by x plus 2 inside the absolute value bars, and down 3 is minus 3. So there's the equation that represents this graph using my transformations. Okay, our next task is going to be to solve our absolute value equations. So the absolute value of a number represents the distance that number is away from 0. So if I took a number line and I took the point, say, negative 2, and I asked you how far away from 0 is negative 2? Well, you would say that it was 2 spaces away from 0. The absolute value of negative 2 is 2. Now, what if I gave you some unknown number and I said, well, I have a number I'm thinking of, and the distance away from 0 is 5? Well, I didn't tell you which direction to go, so that could be over here at positive 5, or it could be down here at negative 5. So when I solve my absolute value equations, I have to take both of those into account. So that's what this means. If the absolute value of x is some number, c stands for a constant number, then x is that number, or x is the opposite of that number. So that's what we're going to do when we solve our absolute value equations. So here we have the absolute value of 2x equals 4. That goes into 2 separate equations. It could mean that 2x equals 4, or it could mean that 2x equals negative 4. And I'm going to solve both of those and get 2 answers. So I divide both sides by 2, x is 2, or divide both sides by 2, x is negative 2. There are 2 possible answers. So if I go 2 times 2 is 4, the absolute value of 4 is 4. Or if I put in negative 2, 2 times negative 2 is negative 4, and the absolute value of negative 4 is 4. So we have to look at both answers to an absolute value problem. You always have to check for both answers. Well, let's look at the next one. Now on the next one, I notice it's an absolute value, but I also notice there's a 2 outside. So before I solve this, I'm going to put a little note here. I need to isolate the absolute value bars. So whatever is not inside the bars needs to move to the other side. So on this case, I'm going to divide both sides by 2. So now it says the absolute value of x plus 3 equals 3. Now I'm ready to do my 2 separate equations. So make sure you isolate your absolute value bars before you write your 2 equations. And once I write my new equations, I don't need to write the bars again. Now that I've pulled it out to solve 2 separate equations, there are no more bars, but you keep the bars until this point. If I subtract 3 from both sides, x could be 0. And if I subtract 3 from both sides, x could be negative 6. So there are my 2 possible answers to that absolute value problem. And we can plug them back in and check. All right. So here, notice I have absolute value on the numerator of my fraction and a 2 on the bottom. The 2 is not in the bars. So to isolate, I'm going to multiply both sides of my equation times 2. When I because the 2 on the denominator is dividing. So when I multiply by 2, that 2 cancels out and leaves me with the absolute value of 4x plus 3. And on the right side, I get 10. So now I'm going to set up my 2 separate equations. One of them says 4x plus 3 equals 10, and the other one says 4x plus 3 equals negative 10. If I subtract 3 from both sides, I get 7, and then I divide by 4. Now you can just leave that 7 over 4. If you want to turn it into a decimal, you can, but you don't have to. So over here, if I subtract 3 from both sides, I get 4x equals negative 13. So x equals negative 13 over 4. Well, I can't simplify that. If you would like to make it, negative 3.25, you can. Or you could just leave it as a fraction. I think it's less work that way. All right, let's do some more practice. The next one, I've got 2 numbers that are not inside my absolute value bars. There's a negative 4, and then there's a plus 4. So think about the way we normally solve equations. In the normal process of solving equations, I would subtract 4 from both sides first, and then I would do the division part last. So let's start there. If I subtract 4, now be careful to copy the rest of the equation just as it is, and I get equals negative 12. Now it's just like the previous question where I divide both sides by negative 4, and I get absolute x minus 2 equals 3. So now I go to my 2 separate equations. X minus 2 equals 3, and x minus 2 equals negative 3. So my solution, when I add 2 to both sides, x could be 5, or if I add 2 to both sides over here, x could be negative 1. So it's either 5 or negative 1. They both make that a true statement. All right, take a look at the next one. Notice there are no numbers outside of the bars, so I can just go straight to my 2 equations. One of the equations says x over 3 equals 6, and the other equation says x over 3 equals negative 6. So to solve these, I multiply both sides by 3. So I get x equals 18. I multiply both sides by 3, x could be negative 18. And there are my 2 possible answers. The next one, also, there are no numbers on the outside, So I go straight to my two separate equations. 3x minus 1 equals negative 5. Uh-oh, I just noticed a problem. Can the absolute value equal a negative? Remember we talked about the fact that the absolute value was the distance from 0? It represents a distance from 0. Can a distance be negative? So when someone asks you how far you live from school, you don't say, I live negative 5 miles. We don't talk about distance that way. So the absolute value of x can never equal a negative number. So this one has no solution. If you had solved it, you would have gotten two answers. But when you checked those answers would not have worked. So that's why it's always a good idea to go back with your calculator and double check your answers. The absolute value can never equal a negative. Well, let's try this next example. Now, we've got a big equation here. It equals a negative, but don't stop there. Notice that we've got some numbers outside that need to be dealt with, the 4 and the negative 9. Now, be really careful here, because if my equation said 4 minus 9x equals negative 14, I would not combine the 4 and the negative 9 to say that was negative 5x. That's not how algebra works. I would subtract the 4 from both sides, and I would leave that negative 9 to divide out later. So do the same thing here. Do not combine those, because the negative 9 is being multiplied by the absolute value. So I'm going to subtract 4 from both sides, and I'll get negative 9, absolute value, negative 6 minus x equals negative 18. Also, notice you cannot distribute the negative 9 into the absolute value bars. Those are like prison bars. You cannot get through those. It's not like parentheses. There's no distributive property here. We will divide both sides by negative 9 and get absolute negative 6 minus x equals 2. Now that I've got my absolute value bars isolated, I can write my two separate equations. So I'll do them over here. Negative 6 minus x equals 2. And then I will also solve negative 6 minus x equals negative 2. So up here, I'm going to add 6 to both sides and get negative x equals 8. And then I'm going to divide by negative 1, and x is going to equal negative 8. On this one, I'll do the same thing. I'm going to add 6 to both sides, and I'll get negative x equals 4. And when I divide both sides by negative 1, I get x equals negative 4. Now, I gave you the advice to double check these answers, especially on that big long equation. So I'm going to plug in negative 8 in here and see what happens. So if I do negative 6 minus negative 8, I get 2. So now I'm going to type in 4 minus 9 times 2 is negative 14. It worked. Let's try that with negative 4. Negative 6 minus negative 4 is negative 2. The absolute value of negative 2 is positive 2. So 4 minus 9 times 2 is negative 14. So they both work, but you have to check them carefully. All right, let's see what else is on our notes today. That is it for the notes today. So some refreshers: be very careful. Remember to isolate your your absolute value before you start solving. And once it's isolated, you write your two separate equations without the bars.